Hello guys, this is Jeffrey. Excited to post our first video. So today's question is from the third chapter of Form 4 Physics, Gravitation. And this question resembles question number 10 from the performance evaluation at the end of your chapter in textbook. Here we are given three different bodies, Q, R and S. And in the beginning of the question, we are being told that the gravitational force between Q and R is M. So we all know that the formula for gravitational force is G, which is gravitational constant, multiplied with the mass of both bodies, divided by the distance between the both bodies, square it, and you will get the gravitational force. So if we translate the first line here into an equation, this is what we get. G mq mr divided by r qr square equals to m. And now this question wants us to state the gravitational force between r and s and q and s in terms of m. They do not want a number, but they want it in terms of a variable. So the approach will be simple. We will write the equation for the gravitational force between the two bodies and equate it with the equation of m and see if it balances on both sides. If it doesn't balance, then we will balance it. Let's look how the approach works like. To save time, I have already written down the equations here. As I said, the first section wants us the gravitational force between R and S. So on the left in yellow is the equation for gravitational force between R and S. G mr ms divided by r rs squared equals to, on the red is the equation for m. Now we need to check if they are balancing with each other. Here we have distance for rs, here we have distance for qr. qr is 5 meters, rs is 5 meters. They are equal. In the numerator we have g both sides, mr both sides. What is different is we have ms on the left and mq on the right. ms is 200 kg, mq is 100 kg. So we need to multiply mq with 2 so that we will get 200. Now they are balancing on both sides, and here the portion in red is equals to m. What we have added is a 2. So if we simplify it, it becomes 2m. That's it. This is the gravitational force between R and S in terms of m. It is equal to 2m. If we interpret it, let's say the gravitational force between Q and R is 5. The gravitational force between R and S will be 10. Why it is 2 times greater? Because one of the mass, this one, is 2 times greater. Okay, let's move on to second section. Approach is similar. Second section wants the gravitational force between Q and S. So in yellow is the equation for gravitational force between Q and S, and in red is the equation for m. Now we need to check if they are equal. Here distance between Q and S is 10 meters. Here distance between Q and R, 5 meters. So to make them equal, we need to add a 2. In the numerator we have G on both sides, MQ on both sides. The difference is MS on the left and MR on the right. ms is 200, mr is 100. So you need to multiply mr with a 2. So just like what we did before, the portion in red is m. What we have added is a 2 divided by 2. Don't forget to square it. 2 squared. So it's a 2 divided by 4. 2 over 4 is half, so you can write it 0.5 m. If we interpret it, let's say, just like before, let's say the gravitational force between Q and R is 5. So the gravitational force between Q and S will be 2.5. Why it is smaller? Because the distance between Q and S is 2 times greater compared to Q and R. Now, just look briefly at the theory. The gravitational force between two bodies depends on two factors. One is the mass of the bodies, and the other one is the distance between the two bodies. If the mass increases, the force increases. That's why we say mass is directly proportional to gravitational force. On the other hand, if the distance increases, the gravitational force between them decreases. That's why we say distance is inversely proportional to the gravitational force. Now, for further information, please refer to your description for links to other YouTube videos on gravitational force. That's all for our question today. If you like our video, please click the like button, share it with your friends, and subscribe to our channel. Click the bell icon for instant notifications on our new videos. And please feel free, if you need any help with your physics revision questions, please post it in the comment section. We will attempt it, come up with the videos, and notify you soon. That's all for today, guys. Until I see you in another video, it's goodbye from Jeffrey. Bye bye.